Hi everyone, I'm Dr. Megan Mulhall and I'm a human factors research scientist from Seeing Machines, and I'm here today to talk to you all about how driver monitoring can help you guys achieve safer fleets and get everyone home safely. So Seeing Machines is a company that was founded on the basis of scientific research, with the company spinning out of the Australian National University in the year 2000. Today, we maintain close ties with the scientific community, collaborating with many universities to help us understand human state and behaviour in order to achieve our vision of zero transport fatalities. So today we operate across a wide range of transport sectors, including rail, aviation and automotive, but we started our journey with driver monitoring in the large haul trucks in the mining industry and in the heavy vehicle industry. And we're still passionate about those sectors today and very active in those fields as well. So as a company, we research, design and build operator state monitoring technology, which allows us to have real-time insights into operator state and understand when that state may have significant safety consequences. So whether that be an operator impaired by fatigue, for example, or a driver not paying attention to the road. So why should we care about driver monitoring? So thousands of people die on our roads around the world every year, and a large proportion of these accidents involve human error and may have been preventable. So every year, 30,000 people are seriously injured or killed on UK roads every year, and a large proportion of these accidents are the result of risky driver states. So when we look at heavy vehicle accidents, about just under 20% of all fatalities involving heavy goods vehicles involve driver fatigue, and 43% of all heavy vehicle accidents in the UK involve some form of driver impairment or distraction. So not only is there a heavy human cost associated with impairment-related accidents, but there can be a substantial financial cost as well, even associated with minor crashes through damage to goods and vehicles. And at Seeing Machines, we believe that driver monitoring systems are a critical safety technology that allows for the possibility of reducing the number of impairment-related crashes. So what is driver monitoring? So a driver monitoring system, or DMS, is a technology designed with the goal of gathering information and understanding the driver themselves. So whether that be to understand something about the driver physiology, such as whether they're fatigued or sleeping, or the driver's cognitive state, such as whether they're distracted and not paying attention to the road. There are currently two distinct types of DMS emerging in the market, so the indirect and direct DMS systems. Indirect systems try to infer information about the driver state through driver performance inputs. So are the drivers staying within the lane, or are they braking harshly, for example? Whereas direct systems are typically camera-based systems that use driver-facing cameras to monitor driver behaviour in real time. So it's possible to understand information about a driver state through physiological signals. So for example, an individual who's experiencing drowsiness is likely to show symptoms such as slowing blinks and long extended eye closures. So at Seeing Machines, the way we understand driver behaviour is through a camera-based direct DMS, and our DMS can track head and eye movements, as well as other behaviours for the driver to inform us about their distraction and their drowsiness state. So we can infer information about a driver's attention from their gaze behaviour. So are they looking at the road or aren't they? And if they are looking at the road, if they aren't looking at the road, where are they looking? So this is an example of our automotive occupant monitoring system. So I apologise, it is a car cabin and not a truck, but this is the best example I can find to show off all of the features of the DMS. So in this case, the product tracks the occupant and the driver, although our trucking product is limited to tracking the driver. So you can see that as soon as the driver enters the vehicle, the system is able to start monitoring and tracking the driver's gaze, along with head position and body pose to tell information about where the driver's looking. So currently the driver was just looking off-road and it marked him as distracted. And then once his gaze has returned to the road, it marks him as attentive. So it can detect a bunch of different features. So you can see on the left, the occupant is talking on the phone, and the system is actually able to pick up from the driver's body position and from the phone itself that the driver is talking on the phone. And then when he hands the phone to the driver, it's also able to detect that the driver's talking on the phone and speaking. So it's able to do these things even in the presence of certain noise factors. So you can see that the driver's wearing glasses, but it's still able to track his gaze, for example. And the occupant in this case is wearing a face mask as well. So it's able to track elements of driver behaviour even in the presence of factors that may be making the tracking of the driver more difficult. So we know that driver state plays a major role in the safety outcome of both the individual driver as well as those around them on the road. So impaired driver states such as distraction, workload, drowsiness, all have roll-on effects when it comes to driving performance. So performance impacts such as lane weaving, lane excursions, slower reaction times, short headway, short distance between the car in front of you can all result in real-world outcomes, safety outcomes, and the safety implications of such performance decrements can include a whole bunch of different types of accidents, which can result in serious injury, fatality. But when you consider the safety features within a vehicle, the vast majority of safety features are trying to operate within the two right-hand blue bubbles on the screen. So you can think of most safety features are trying to either correct some sort of performance impairment that's caused by the driver's state to reduce crash likelihood, or they're trying to impact the outcome of the crash itself. So when you think of a lane departure warning, for example, that's trying to prevent crashes by targeting the performance impacts of the driver's state, whereas seatbelts are trying to impact the outcome of the crash itself. DMS is almost unique in the way that it's trying to provide a safety benefit, in that where other technologies are trying to stop the impact on performance, DMS is targeting the root cause of the impairment itself. So due to the potential of DMS to provide safety gains across a range of impairment types, there's been increasing attempts to regulate and encourage DMS uptake. So what this looks like in a European regulatory context, the two main bodies who are looking at DMS at the moment are Euro NCAP, which is a consumer advocacy and advice program, and the European Commission, which informs the regulation. So Euro NCAP for cars has included direct driver monitoring in their safety protocols from 2023. And this includes things like drowsiness, microsleep, sleep, and distraction monitoring. And then from starting this year, Euro NCAP has also announced Euro NCAP for trucks. So they'll be bringing their testing and safety protocols into the truck environment as opposed to just the commercial vehicle environment for the first time. And this will include from 2024 indirect driver monitoring and is likely to include direct driver monitoring from 2027. The European Commission, on the other hand, is a regulatory body, so they mandate laws and regulations and requirements, whereas Euro NCAP is consumer advice. So the European Commission has had a requirement for all new vehicles to have a drowsiness driver monitoring system from 2024, and all new models to have a distraction driver monitoring from 2024, with all new vehicles having distraction from 2026. So what this looks like in a UK context might be a little bit different. So the European Commission GSR requirements are a legal requirement for new vehicles in the EU to include driver monitoring. So while these regulations don't necessarily apply within the UK, it's likely to impact operators that travel outside of the United Kingdom. And following on from the momentum of the European Commission mandating driver monitoring systems, there's been a push from many transport safety groups and groups within the UK for DMS to be required in fleets And so it's likely that some form of the European Commission's standards will be adopted in the UK in the future. And before that happens, many industry groups are actually deciding to self-adopt DMS as the safety standard as well. So, for example, the international oil and gas industry is currently looking at whether DMS should be the minimum safety standard for their fleets. So regardless of whether any of these regulations directly apply to you and your fleet, what the GSR standards do mean is that there will be a significant jump in the availability of driver monitoring systems within your market, and you'll be seeing a lot more DMS availability in the future. So the general safety requirements, however, are a relatively low bar for safety performance. So while they're critical in regulating safety across the DMS industry, they create a minimum performance standard for DMS, as opposed to Euro NCAP, which is essentially trying to push for better and more advanced safety standards among DMS systems. So previously, the Euro NCAP guidance only applied to passenger vehicles, but they have now announced they'll be expanding the track testing for trucks. So this is, I think, excellent news for the safety conscious fleet operators, because heavy vehicle manufacturers have long fallen behind in the development and manufacture of safety systems for heavy vehicles. In commercial vehicles, there's a large suite of ADAS systems, so advanced driver assistance systems, with everything from reversing cameras to blind spot detectors, assisted lane keeping. The list is nearly endless. And I'm sure many of you who have experienced those systems in cars thought it would be nice if we could have this in our trucks. But when it comes to safety systems in vehicles, manufacturers almost across the board have invested far less into new safety technologies for keeping truck drivers safe. So the goal of the Euro NCAP for trucks is essentially designed to challenge and push manufacturers to invest in their heavy vehicle products and give consumers a way to understand how safe the truck they're purchasing actually is. So as part of the Euro NCAP for trucks program, indirect monitoring systems will be required in vehicles from 2024 and direct monitoring from 2027 to achieve a 5-star safety rating. But we already have a very good idea of what that would look like if we brought the Euro NCAP automotive requirements into the trucking industry. So direct driver monitoring has already been included in the Euro NCAP protocols. So as you can see, the list of required behaviours for DMS is quite a bit longer than the one for GSR, as Euro NCAP requires greater complexity from DMS systems. So for example, for distraction, long glances off-road need to be detected, and that's similar to what's required within GSR. But shorter VATS distraction is also a requirement. So where drivers are conducting multiple short glances between the road and another object. So for example, their phone or somewhere within the cabin, as well as phone detection. Although this isn't a requirement for detecting the phone object itself, it's a requirement for detecting the gaze behaviour that comes along with phone use. So for drowsiness, there is a requirement to detect when drivers are drowsy, so when they're experiencing high levels of sleepiness, and that's similar to what's seen in GSR. But there's also an additional components for detecting microsleeps and detecting sleep events, as well as when a driver becomes unresponsive. So there's quite a few more requirements within Euro NCAP than what we see in GSR. So when we're talking about translating regulation from an automotive environment into a trucking environment, we need to be considerate of the fact that drivers are likely to behave differently in a truck cabin than they are in an automotive space. So not only is it a different environment, these are also professional drivers, and so they behave a little bit differently. So how do we adapt the standards that were developed for an automotive context into a heavy vehicle context? So this is an example of data from Seeing Machines comparing glance behaviour between car drivers on the left and heavy vehicle drivers on the right. So the first data set is shift workers commuting home from their work shifts in an instrumented vehicle, and then the data set on the right is a fleet that was instrumented with Seeing Machines automotive grade eye tracking to understand more about their gaze behaviour. So on the surface, when we look at these, it looks like truck drivers have a similar number of long glance away alerts. So that's when drivers glance off road for a longer period of time, so around 3 seconds. But when we actually dig into the data a little bit more, we can see slight differences in the glance patterns between truck drivers and automotive drivers. So we see truck drivers actually spend a lot longer looking at driving related regions, unsurprisingly. So they're spending a lot more time looking at their driver mirrors relative to car drivers. Whereas car drivers are a lot more likely to be spending time looking at non-driving related regions. So for example, playing with their center console. So what this highlights is the importance of considering differences between the car and the truck drivers when adapting the NCAP standards into the truck cabin environment. So the Euro NCAP distraction standards also include more complex types of distraction behaviours compared to the GSR standards. So one example of this is the requirement to detect both lizard and owl glances. So owls typically glance around by moving their head. Lizards will typically move their eyes. Humans are fortunate enough that we're able to do both. And so there's different strategies that we use when we're glancing at different regions. So for example, you might turn your head to look out the passenger side window, or you might just move your eyes to look at the driver mirror. So this is important because some DMS systems will only detect distraction behaviours where the head is turned away from the forward roadway, and they won't actually use gaze to measure distraction because that requires a much higher level of tracking sophistication and is much more difficult to do. But as you can imagine, this leaves a large safety gap where drivers won't be detected as distracted if they glance off-road with just their eyes. And it's critical because this is the kind of pattern we see in high-risk behaviours such as glancing down at your phone, for example. You're much more likely to be using a lizard glance pattern. So another example of more complex distraction behaviour is multi-glance distraction, where drivers make multiple glances off-road to a phone, for example. So in this case, you can see instead of staring for a longer period of time, the driver is making multiple short glances between the road and an object. So while there's range in the complexity of behaviours, there's also environmental factors that can impair tracking in DMS, and they're very common in the real world. So while it's relatively less complex to track someone's eye movements when their face and eyes are really clear and visible to see, the level of difficulty increases in the real world as the driver may be wearing reading glasses or sunglasses, for example. There's also cases of interference, so where the light might be shining directly in the camera, for example. And some DMS systems may be able to monitor complex behaviours, but they're unable to do this under difficult but realistic driving conditions. So thus, it's important when understanding driver monitoring systems to understand and not just think about it as a tick box of do they have distraction, yes or no? Do they have drowsiness, yes or no? Because not all distraction algorithms are designed equally. When considering DMS, we need to consider not just the complexity of the behaviours they're detecting and the safety coverage that actually gives you, but what conditions we can measure these behaviours under, because a system that doesn't work under real world conditions is a DMS that just doesn't work, no matter how well the algorithms perform under perfect simulated research conditions. So just as there's varying complexity with distraction, there are also varying complexities to drowsiness behaviours. So detecting someone who is sleeping, for example, is relatively easy, but I'm sure most of you would agree we would prefer to be able to intervene before a driver falls asleep. Whereas detecting a driver who's micro-sleeping or a driver who's drowsy but not yet falling asleep is an increasingly difficult task, particularly under real-world conditions where the eyes may not always be visible. It's very difficult to track, to detect if a driver is drowsy, for example, if you can't track their eye closures because they're wearing dark sunglasses, for example. So we design our DMS strategy at Seeing Machines in a way that allows us to help navigate this complexity. So we have many data sets that we utilize for algorithm development and navigating tracking complexity. So we leverage this research that we conduct both internally and with our university partners. We use simulators and test tracks to get a really deep understanding of driver state under controlled conditions. But then we use our real-world on-road research to understand not just the complexity and the variability of real-world driving, but also the real-world safety risk. So all that research has gone into our new Guardian Gen 3 product. So I'm going to play a couple of videos just to introduce you to that product.
In the pursuit of safer roads, Guardian Generation 3 breaks new ground as a leading safety solution that goes beyond traditional approaches to driver distraction. By meticulously tracking the eyes, not just the head, the automotive-grade technology provides a more accurate indication of the driver's focus. Detecting continuous and repeated off-road glances, Guardian Generation 3 reliably identifies risky periods of inattention and intervenes promptly to redirect the driver's attention back to the critical task at hand, so everyone gets home safely.
So that was about our distraction monitoring in our Guardian product, and then this following video is about the
In a notoriously high-risk industry where safety is paramount, Guardian Generation 3 takes the lead by continuously evaluating a driver's level of drowsiness and intervening in real time before fatigue escalates or sleep occurs. Through this proactive approach, drivers are made aware of their heightened risk by alerts tailored to the specific situation so they can take action. Fleet operations also have real-time information regarding drivers experiencing elevated drowsiness levels, allowing for swift responses to ensure their people get home safely. Introducing Guardian Generation 3.
Okay, so now that the marketing videos have introduced you to the Gen 3 system, let me walk you through what it is that I like about the Guardian system. And that is that it works on so many different levels to provide a layered protection for drivers. So firstly, it detects driver states. So even within this, there's multiple layers of protection. So detecting drowsiness is very hard. So where a system may fail to detect a particular driver as drowsy, we are likely to detect them if they have microsleep or if they fall asleep. So it's offering multiple levels of protection there just within the detection of the driver's state. Next comes the in-cabin alerts. So where a driver is immediately alerted to their risky state or behaviour. So for example, if they were detected as drowsy, they would get an immediate alert. So these alerts are multimodal, so meaning that there's different types of alerts, such as vibration, audio and visual alerts, and this increases the chances of those alerts being perceived by the driver. So for example, if somebody is having a microsleep or has fallen asleep, they're unlikely to be awoken by a visual alert or an audio alert. And so the haptic vibration alert allows an additional layer of protection to wake somebody up if they were in that state, making sure that those alerts are actually perceived and protecting the driver in that immediate moment. Following the immediate in-cabin alerts, events are then sent through to our trained analysts in our Guardian Centre, where they will review the alert and where appropriate, they can activate a fatigue intervention plan. So this is contacting operators and shift supervisors to inform them of their driver having a fatigue event. So this allows operators to be informed of their driver's state and make preemptive decisions for their safety before an incident occurs. Finally, operators also receive monthly data from the Guardian Centre about how many fatigue events and events have occurred in their fleet. And so that can be used to provide data insights as well to target long-term safety benefits. So the best thing about this system is that we know it works and we've proven that it works. So in a study conducted with Monash University Accident Research Centre, which is a university in Melbourne, Australia, in collaboration with Seeing Machines. Our Guardian product was fitted into an active fleet of vehicles, but alarms were initially silenced to provide a baseline of the number of fatigue events within that fleet. So once we had acquired a baseline, alarms were turned on to examine how the driver behaviour changed using the in-cabin alerts. So when drivers received in-cabin alerts alone, so that's the audio and haptic alerts within the cabin, it reduced fatigue events by 66% relative to baseline. So this demonstrates that the in-cabin real-time alerts allow drivers to be aware of their risky state and almost self-coach to reduce those events long-term. So maybe they might think, okay, I had a lot of fatigue events today. I might need to prioritize my sleep tonight, for example. But the real magic happens when the in-cab alerts were combined with contacting a company's shift manager to tell them that their driver had just had a fatigue event. And we then saw a 94% reduction in fatigue events. So the system as a whole is really effective, but implementing a full system intervention plan was key for reducing those fatigue events. And so we know at least part of that safety benefit comes from data insights and operators coaching drivers who receive those fatigue events. So fleet operators receive monthly data on the number of fatigue events in addition to calls when a fatigue intervention plan is activated. So this data can actually be used by operators for a number of purposes. So the most important is to identify drivers at high risk for fatigue, particularly drivers who are having many more events than other drivers, because this allows operators to have a chat with those drivers and actually discuss factors that may be putting the driver at risk. So this has been used successfully by our customers to identify drivers, for example, who might be at risk of sleep disorders such as obstructive sleep apnea, which is really common in truck drivers, but also really hard to detect if you don't know that you have it. So this allows operators to support their drivers in identifying that it may be a medical issue and seeking treatment. Whereas in other cases, it might be lifestyle factors and they may need some strategies to be put in place to help them prioritize their sleep and make sure that they're fit for duty. So the data can also be used by operators to help identify overall safety trends within the fleet as well. So for example, is there a particular time or a particular route or a particular shift where operators are at higher risk for fatigue, and are there any strategies we can put in place to counteract that and mitigate some of that risk? So one last thing I wanted to touch on before I finish up is the issue of privacy. So I want to make it clear that Guardian is a closed loop system. So it may be a driver monitoring system, but it's not a driver surveillance system. So operators are not able to log in and view video feed of drivers. Video is only accessible after an event has been generated, after it's detected by our DMS, and if it's sent for review to the Guardian Centre. So the exception to this is the retrieval of black box data from the Guardian unit in the event of a crash, where a short amount of footage is retained and can be reviewed to help identify driver state prior to the crash.